Hello and thanks for joining me. Well, today we're going to build a CBN grinder. I got this really cheap CBN grinding wheel on eBay. It's kind of a cup wheel, so it requires a little bit different kind of grinder. Most of them I've seen are 8-inch and made like a regular grinding wheel, and that's probably preferable, but they cost considerably more. I just paid 23 bucks for this. So it's worth, I got the steel and I got an old surplus motor. It's worth making the effort to set up this grinder. But if you haven't heard of CBN, CBN is a material, I can't remember what it stands for, but they put it on the surface of these grinding wheels and it lasts just about forever. But it's only for high-speed steel, not for mild steel, and it's not for carbide. You got to get a diamond wheel for carbide. But anyway, that's what we're going to build today, so let's get started. Well, I picked up a good deal here. It's about a 4.5-inch, 4 5/8 inch CBN wheel, 60 grit. CBN is by far the best abrasive to use on high-speed steel. But I have nothing to run this on. No grinder that'll mount that type of wheel. It's got a countersink in the middle for one bolt, and then it's got a couple other holes there. So I'm going to build something to run that on. I'm going to maybe mount some bearings in that, put a little faceplate on there, and use that ugly motor there. So I guess the first step is to clean up that ugly motor. Yeah, this motor's pretty nasty. Picked up I think it's about 15 motors for 100 bucks, and this is one of them. I managed to get about 6 of them running. I've used several of them. This one's in pretty rough shape, but I believe it'll be a good motor. Little mud dauber in there, that'll stop that centrifugal switch. Well, it still runs. That's a good sign. I didn't get it cleaned up super good, but it looks a lot better than it did. Okay, this is going to go through here. It's like that. I got cut a couple of bearing fits in here. Hopefully there's enough, just about the right size for the bearing. I hope I got enough meat on that tube to make it fit. We'll see. Okay, I got a hole saw in here. I don't know if it's a good enough quality hole saw to drill through a 1/4 inch of steel, but we'll see. Looking pretty good. Now it's time to make the, I guess you'd call it a faceplate for that grinding wheel. Okay, I got that flipped over in the chuck. I'm going to true up that cut edge there. I made this, the hole in the disc slightly under 5/8, made it 5/50, and then I turned the shaft down to be a press fit into that disc. That way I got a little ledge that the shaft will hit. That's a very tight fit. What I want to do, I want to undercut the center about 2/1000ths so that it seats perfectly here and is drawn in the middle a little bit. Okay, what I'm doing here is I got my steady rest set up here, and the reason I'm doing that is because the chuck is probably not concentric. I know it isn't. It's probably about 2/1000ths off, and I want my grinding stone to be very true. Also, it may be dead on right here, but a foot out from the chuck, it's probably got a wobble. So if I put that in there and drill a hole on the disc and have it up against my chuck, it's not only is it going to be 2/1000ths off this way, it could be off this way too. So if you'll notice here, this disc is wobbling a little bit. But by using my steady rest to steady that the end of that rod, the amount of error that I'm going to have is going to be extremely minimal. So I'll drill my center hole while I'm supported with the steady rest. Pulled that out a little bit. I don't want to mar my shaft where the bearing is going to fit. Something's loose. Now I'm going to do two things. I messed up. I need my carriage on this side. Okay, now I can resurface a tiny bit of this face right here. Yeah, it looks like that tap is wobbling a little bit. That's not a good thing. Wow, I'm off center. Well, I replaced the screw, and now I got 4 or 5 thousandths run out. I had about 20. So the screws are not ideally accurate. Kind of questioned the this method of mounting, but that's what the stone came with, what the wheel came with. Okay, I got a plan. That is bigger, this shoulder bolt is bigger than the center hole on that wheel, I mean on the grinding stone. So I'm going to turn this down. I think I'm going to use a different tool though. I got that Loctited in there. And I'm going to turn the head of it off and then turn the body to the same diameter as the stone. Now what I need to do, I'll cut that shaft off a little bit and I'll drill 2 holes, 2 mounting holes right there. I now got 1 hole perfectly lined up, and this drill size is exactly what's in the wheel, in the grinding wheel. So we got to cut that shaft off to length, weld that in there, cut a keyway in the shaft, and weld this to the base, and mount the motor, and then I think I got to buy a belt to fit. It's a real short belt. I don't think this one will work. Well, I wonder if that shrunk when I welded it. How am I going to fix that? Yeah, I can see where it's kind of egg-shaped. Wow. Yeah, I don't have a belt the right size, but I made a polyurethane round belt. It's not the right kind of belt, it won't hold up, but good for a test. Well, I took the motor apart again and cleaned the contacts to the starter. And it starts up good now. The squeaking noise you hear is this poly belt. Three and a quarter divided by 2 is 1 5/8. Yeah, I think that's deep enough, just needs to be a little wider. Well, I haven't got any kind of chamfering end mill, so I'm going to use a round nose. I'm going to cut a relief right there so that I can tilt the table up against the stone and still have it close to the stone. That relief right there lets it pivot down like that and still remain close to the stone, relatively anyway. Looks kind of funky, but I think it'll work good. Let's give it a try. Nice looking surface grind, eh? I've got the correct kind of belt coming for this. It's not here yet. This works pretty good though. Well, there it is, all done. I'm going to have to educate myself on the proper grinding angles. I usually use carbide for convenience. High-speed steel does work better, especially on a lower power lathe. It's just a whole lot sharper than carbide. But let's see how it works. Yeah, let's give this a try. It's a very crude grind, but see what it does. Not much of a chip breaker, but boy, it's cutting smooth. Wow, that's glass smooth. Well, that about wraps it up. Thanks for joining me, and be sure and subscribe.